Okay, so this is my third video about explaining intelligence. So to start off with, um, the parietal lobe of the brain does spatial awareness. So it gets information from the occipital lobe and the temporal lobe to place objects where they are in space, and also to place yourself in space. So that the it works with the sensory motor cortex, and the way it does that is like the body is in a specific location. Like my hand can be over here, or my other hand can be here. It can be anywhere, but you're supposed to locate yourself in space, and the parietal lobe does that with the sensory motor cortex. And then with intelligence is that there's in the front of the brain there's an area that connects the parietal lobe, and it goes back and forth with feedback to actually probe the environment to see what it can do. So like for example, little babies, they are just trying to understand themselves first. They're trying to understand where their body is, because to coordinate just like what they do with their body, to and when they're like 3 years old, they're like running and doing all those things, but it's not there yet that they actually well, it is there when they play with toys and stuff like that. They're gaining a feel for the spatial awareness that is in their parietal lobe. And so the thing is that when this part of the brain that's in the front goes back and forth with feedback between the parietal lobe and that frontal area in the brain, it's actually probing the environment. That's how we're able to say, like, oh, I touched a hot stove and that wasn't good, and so like now I know that if it's glowing and it's near me, I should not put my hand in that direction again. So and another thing is that, like, if you have blocks, like put the triangle in the triangle hole, put the circle in the circle hole, put the square in the square hole, the pegs, put the pegs in the holes. So the thing is that that's something that this will do, is that it will see, oh well, the triangle does not fit in the square, and the square does not fit in the circle, and it's like you have to match them up to put them in there. And so that spatial aware, that the probing will eventually get there, that you can see what you can do and what you can't do, what you can and can't. So and then there's another area in the brain that's even further in front of the area that's connected to the parietal lobe, and those connect to, those two frontal areas connect together in order to form hypothesis. So the thing is that when the parietal lobe and the front of the brain are sending feedback to each other, this area of the brain that's in the front goes back and forth to see it creates random generated information so that it can plan things. So the thing is, like, working memory will like peter out. You know, it'll just like go away if you're only doing the trial and error. So when you're doing trial and error, you're not really learning from a top level perspective. So that's why this frontal area of the brain that connects back to the part of the front of the brain that connects to the parietal lobe, these three areas working together actually come up with things that, like, oh, what if I do this, or what if I do that? And so the thing is that this other area is like a meta area. It's like a metacognitive area almost. So it says, okay, so I can see how that when you're probing the parietal lobe in this way, you get this result, or if you probe it in another way, you get this result. So I will have, so it's gathering information about the trial and error, and then when you get to a point where you're stuck, when you don't know what to do, this area will generate signals, and it'll go back and forth, and this is going back and forth in the head. It's not going back and forth in the environment. So by going back and forth in the head with these two frontal areas, you're able to say, oh, well, this plan might work. No, that's a bad plan. No, this one will only work sometimes. This one works all the times. Usually, when I come across novel problems like this, and so it'll plan out things in the head by not actually physically touching the environment, but just like taking all the information that we already know that has been probed from the environment, and then go back and forth inside those two areas, and then execute a plan to make try to solve the problem. And the thing is that, and then there's the bottom of, it's like right there at the bottom of the brain, and the anterior cingulate cortex, and that deals with people. So the thing is that a psychopath can work with all three of those areas. The thing is that the bottom of the brain works with people. So the thing is, like, if you treat a person as an object just to get what you want, then you probably are psychopathic. But if you use the bottom that's below it's the bottom of the frontal lobes, so the thing is, that's where it connects it to, oh, you're a person, I can't use you in this way or that way or whatever, because that's immoral and stuff like that. So that's what that part of the brain does. So what it does is that it monitors the behaviors from other people. So it says, okay, well, he did this and she did that, and so, like, Jimmy stole from Kyle, and so maybe I should tell Jimmy he shouldn't do that, and stuff like that. That's the bottom of the brain. And so I guess in intelligence, that those three areas and also the bottom of the brain work together to just do what you have to do. But what I did not explain too well is that the feedback inside the brain. So when a kid is exploring, he's playing with toys and stuff, he's trial and error exploring. And so the thing is that when a person uses their brain to to mentally simulate what's going on, that so it has to fill itself up, right? So, like, a little kid doesn't really know about school and stuff like that. So it's like a 4-year-old is not doing calculus. So the thing is that when we have our brains and they're building up all this information, once a whole bunch of information is collected, then that means that when it's going back and forth inside the brain, it's doing a lot. If you know a lot more, then you can do a lot more, or you can think a lot more. You can get information, get enough information, and combine it, and then you have expertise. So the thing is, like, that's why adults have so much experience that they don't really have to do trial and error anymore. They can just think up. Come across problems and they think up solutions, and they do it like that, you know. So it's like getting older means that you can solve problems faster because the information is coordinating in your brain a lot more. So when it's being filled in, it's delay. You know, the feedback has a delay. So in order to account for the delay, what the brain has to do is come up with what's going to happen next. It has to predict things. So the thing is that like I said, this part of the brain is probably like the meta part of the brain. So the thing is that like it has well, the whole brain has connections going back and forth between each other. So the thing is like, in order to predict things, it has to just like well, I'm not exactly sure how this works because of the delay. So the thing is that like you send something out and then it comes back, and then you know that it's happened. So it's sort of like walking, right? So when you're walking down the street and you trip over a rock, you sometimes you fall down and sometimes like you recover. So if the feedback would have to go at a fast pace, you know. So it's like you trip over a rock and you don't fall down because you got your nervous system had the right feedback at the time to like coordinate itself, and so like I think that is actually done by the cerebellum, because the cerebellum actually intertwines with it's not just for muscle movement. It's actually to coordinate the entire brain, because if the brain is not coordinated, then it's not really using the feedback correctly to to probe the environment, and also to come up with hypotheses to solve the problems. So I guess like the conclusion is that you need these feedback of what works, what doesn't work. So like even in vision, predicting what you see next, the brain is constantly sending signals to the other parts of the brain, and by just like exploring the environment like a little kid, and then getting experience as an adult, what happens is that you're probing, like the hot stove. Don't touch the hot stove. I can put this block. I can put the square peg in the square hole, and it's all like about how the body is able to find. Yeah, so it's just like the body understanding, and then thoughts understanding, getting the feedback from your ability to probe things. Okay, so the frontal lobes has those things where it's like it comes up with hypotheses, and it all starts with like the body in motion. So you're probing the environment to see what you can do, and your brain is thinking about what it can do, and that's just about it.